again. Hello, my dear students. I hope you are all doing well. So, before we go into the lesson, okay, let's build up the energy so that we learn with enthusiasm and with a lot of energy. And again and again. Lil TJ. The name of the song is Too Grown. The chorus part is so good. Not ready with stranger, feel like you like falling for strangers. That'll do. Okay, so this kind of energy is what you need, okay, to start something, to start something big, okay, and to teach you and to come in front of you, okay. I should, okay, prepare myself because teaching is not easy, and then the execution is also very important. So to execute effective teaching, okay, like it is very important to focus on the mode of transfer. So I should give you the knowledge, okay, with energy, enthusiasm, so that you receive with energy and enthusiasm from that end. So let's start a class today. So my dear students, I welcome you all to this channel, Classroom. My name is Benathan Paton, and together we learn, okay. So I have a very important topic for you today. The topic is refining of metals, or in other words, electrolytic refining, because the technique that we will be using to refine the metal will be electrolysis, okay. So electrolysis. Now you are already familiar with electrolytic reduction, okay. We have already discussed the extraction of metals high in the activity series, for which we have discussed electrolytic reduction, the previous video, okay, before this video, the previous video. Please go and check it if you have not watched it, okay, it is there. Then we have also discussed the extraction of metals in the middle series and at the bottom of the activity series. Everything done. We have the metal with us. Let's say this is the metal, okay, this is the metal, but this metal is not 100% pure. That is the problem. This metal is not very pure. I want it in its purest form. So I want this metal to be in its purest form, for which I have one more technique to do, and which is refining. So today we're going to do a very crucial and a very important step, okay, in the metallurgy process. So with this, the whole process comes to an end. So after refining, there is nothing more to do, okay. What can we do after refining? It's already in its pure state, so nothing is there to do beyond that. So remember, okay. So electrolytic refining, okay, to convert a metal to its purest, so that we get the purest form of metal. So we are expecting 100% pure, is it not? Is it not? We want 100% pure. But my dear students, let me tell you, and do not get disappointed, let it not break your heart, but then there is nothing called 100% pure, okay. In this world, nothing is 100% pure. Even elements are not 100% pure, even metals are not 100% pure. So you will never get 100% pure. So what we're after? We're after 99.99% purity, okay. This is the level of purity that we will receive after we perform this refining process, okay. So remember, so our target is to achieve 99.99% pure, and currently the metal that I have with me is not, okay, it's not at this grade. It has not reached this purity level. So that is what we will do. We will bring the metal to this purity level by performing electrolytic refining, okay. So that will be the topic today. Now, which metal are we going to refine? We are going to refine copper. Remember, it's from your syllabus only. In the textbook also, the electrolytic refining is explained about copper. So we will discuss about copper. So we are refining copper metal. Copper metal. So copper metal, we are going to refine copper metal. So our goal is to get 99.99% pure copper, okay. So let us dive into the lesson. Before that, take down the definition of electrolytic refining. So what is electrolytic refining? Electrolytic refining. So let me remind you again, my dear students, that you have to take out your notebook, grab a pen or a pencil, and write down this. Let it serve as a new notes to you, okay. Notes are very important for you. So from exam point of view, all you need is notes. So understand the discussion and have a healthy notes to study. That way you are more than ready to go and write the metric exam. All right. So electrolytic refining. What is the definition of electrolytic refining? Electrolytic refining. Electrolytic refining is the use. Let me erase this one. It's a use of electrical, 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 this is C, electrical. It's a use of electrical energy, it's a use of electrical current, not energy but current to refine metals. This is it, my dear students. This is the definition of electrolytic refining. It is simply the use of electric current to refine metals. Okay, so this is called electrolytic refining. Okay, now let us go further into the topic and let us study the setup. We need a setup. Okay, there is a setup for this one, so let us study the setup. The setup is very important. Now the setup for electrolytic refining will be almost similar to the setup for electrolytic reduction. So we have already discussed electrolytic reduction, so it's going to be almost 95% same. Okay, so let us start with the setup. First of all, we need an electrolytic tank. So let's draw the electrolytic tank. So kindly draw with me. Okay, so this is the electrolytic tank. I think it should be at equal par. Yes, so the name of this is electrolytic tank. Electrolytic tank. Most probably this will be made of glass. Okay, visible see-through glass. Okay, after this, now what you need an electrolyte. Okay, an electrolyte, a solution, an electrolyte to pour into this container. Okay, and on which we will do refining. So we need an electrolyte. So electrolyte, so electrolyte. Now what is an electrolyte? The electrolyte, okay, the electrolyte here should be a salt solution of the metal which we are refining. So the electrolyte, write down the definition. Electrolyte will be a salt solution of the metal to be refined is taken as the electrolyte. All right, my dear students, very important point, very important point. Okay, the electrolyte should be a salt solution of the metal to be refined. So the metal to be refined, which metal are we going to refine? We are going to refine copper. So we are going to take the electrolyte, okay, of copper. So basically we are going to take a salt solution of copper. So we are taking a salt solution of copper, a salt solution. We are taking a salt solution of copper. The salt solution of copper is copper sulfate solution, CuSO4. So we'll be taking CuSO4 solution. So we'll be pouring here CuSO4 solution. So the entire, okay, the entire solution here is CuSO4, copper sulfate solution. Copper sulfate solution is a solution of copper. This is a salt solution of copper. Okay, copper sulfate solution. Now after this, let's go to the next one. The next thing that we need is the electrodes. So we need 2 electrodes. So remember, in the reduction, in the electrolytic reduction also we use 2 electrodes. Here also we'll be using 2 electrodes. Okay, these are the basic features of electrolytic process only. We need electrodes, so we'll be using 2 electrodes here. So let's take 2 electrodes. Let this be one of the electrode, and let this be the other electrode. So this is the other electrode. Now things are different, okay, for the electrodes in refining. Now this, okay, this is the impure metal, that we have with us. Okay, the impure metal that we have with us okay, is made the anode in electrolytic refining. So this is the impure metal, the impure copper. Since we are refining copper, we will be writing impure metal. In our case, it is the copper. The impure copper is made the, okay, what will this be? The negative, the positive terminal will be connected here. So what will this be? Anybody, my dear students, pause the video and think of the answer. What will this be? The positive terminal is connected on this electrode. What is the name of this electrode? Pause the video and think of the answer. Yes, this is the anode. This is going to be the anode. This is the anode. Remember, this is the anode. The positive terminal of the battery, okay, is connected to the anode. So long positive, short negative, positive, negative, positive, negative. And this one, what will this be? The negative terminal of the battery is connected to this electrode. What is the name of this electrode? If this is the anode, then this becomes the, yes, cathode. This is the cathode. So this is the cathode. Okay, so this is the cathode. Now this is the anode is made of the impure metal. Okay, now what will be the cathode made up of? The cathode will also be made up of, okay, something. What will it be? Here the cathode will be made up of pure copper. So a thin strip of pure copper is used as a cathode. So the cathode will be a thin strip of pure copper is used as cathode. So remember this, okay? A thin strip of pure copper is used as cathode. So the cathode is made up of pure copper, whereas the anode is made up of the impure copper. Okay, and we are going to refine this. The impure copper, okay, is what we are refining. Okay, so we are going to refine, okay, and remove all the impurities in the impure copper. Okay, for which this whole process is discussed. Okay, refining, we are discussing refining. Okay, my dear students, we are studying refining. So this is only the pure copper. So all focus here. Okay, this is the impure metal. It has got some impurities in it, whereas along with the impurities, it has got copper, pure copper also. So our goal is to remove the pure copper from this impure copper. Okay, so this is what we are studying. So very soon you will know how we are going to extract the pure copper from this anode. Okay, so now everything done. Now what will happen? Now let's start the process. So when we initiate the process, when current starts flowing, what will happen? First of all, let's discuss about the electrolyte. Okay, the electrolyte here, copper sulfate, okay, CuSO4. CuSO4, what happens is that it undergoes dissociation, means it breaks, it splits into two parts. It will split into Cu2 plus and SO4 2 minus. So CuSO4, okay, the solution, the electrolyte will split into two parts, copper and sulfate part. So it will not remain like this anymore. The entire solution will be split into two parts. We'll have copper 2 plus and SO4 2 minus. So we'll have Cu2 plus and we'll have SO4 2 minus. Okay, we'll have SO4 2 minus, we'll have Cu2 plus. So like that, the entire solution will be split into two parts. Okay, so we have SO4 2 minus, we'll have Cu2 plus. Okay, likewise, the entire solution everywhere, okay, with the flow of current, the copper sulfate solution will dissociate into two parts. I hope you are following. Okay, now, so the solution has dissociated. Now what will happen now? Yes, so this is the negative electrode. Okay, negative electrode. Now look at this copper, look at this copper. Okay, pay attention to the copper. Okay, your interest should go to the copper, all your attention should go to the copper. This is the negative electrode carrying negative charge. So this carries negative charge and this is positive charge. Okay, because anode positive terminal is here, this is negative charge. Negative attracts positive, opposite charges attract each other, is it not? So what will happen? This Cu2 plus will go here, they will go here. Okay, all the Cu2 plus will go towards this because they are attracted to the negative electrode. So Cu2 plus will go here. Okay, when copper Cu2 plus touches the cathode, what will happen? Okay, when Cu2 plus touches on making contact with the cathode, what will happen is that, okay, it will absorb 2 electrons, and then this charge will disappear. On absorbing 2 electrons, this charge will disappear. So Cu2 plus, okay, on absorbing 2 electrons, what will happen? The charge will get cancelled, isn't it? 2 plus 2 minus. So what you get? You get copper. This is the metal copper. This is the metal copper. So when Cu2 plus goes and touches the cathode, what happens? Immediately it will lose its charge, 2 plus. How does it lose a charge? By absorbing 2 electrons. So it absorbs 2 electrons. On touching the cathode, it immediately receives 2 electrons, okay, and then it loses its charge and it turns to copper metal, and it gets deposited here, okay. Likewise, all the Cu2 plus will head towards cathode, touch the cathode, lose the charge, and again it will get deposited here, okay. Now I know what you're wondering. You're wondering, sir, how did they receive these 2 electrons? Okay, now to tell you, to know the origin of these 2 electrons, we have to go back to this part, okay. So we'll go back and focus here. So things are happening here. So remember, this is made up of impure copper, but it also has got copper in it, is not? So the copper here on this anode is in its elemental form, which is in its metal form. So the copper here in the anode is all in its metal form, Cu, okay, in its metal form. Now when current passes through it, what happens? This copper converts into copper ion. So this copper metal converts into copper ion, okay, and jumps into the solution. So this copper metal, okay, loses 2 electron, okay. Remember, metals have the ability to lose electron. When metals lose electron, what happens? They get positive charges, no? So copper on losing 2 electron, if copper loses 2 electron, what will happen? It will gain 2 plus charge. So it will lose 2 electron and gain 2 plus charge. So gaining 2 plus charge means it has lost 2 electron. So copper converts to copper ion, okay, in the process of which it loses 2 electron. So that it loses 2 electron. This 2 electron, it travels all the way, okay, all the way here. It travels all the way here, okay. It travels all the way here, and finally this becomes this one. So the previous question which you were asking, okay, how did this copper ion get this 2 electron? Now you know, it came from this copper, okay, which is in the anode. The copper which is in its metallic form, which is in its elemental form, okay, converts into copper ion by losing 2 electron. So by losing 2 electron, it gets 2 plus charge. So losing 2 electron, it will get 2 plus charge. If it loses 3 electron, it will get 3 plus charge. So the amount of plus charges that a metal gets depends on the amount of electrons they are losing. Since copper loses 2 electrons, it gets 2 plus charge. So this copper which is in the anode, okay, converts to copper ion. After converting to copper ion, it does not stay in the anode, okay, it jumps to the solution. So it contributes to the copper ion in the solution. So the solution starts getting more Cu2 plus, and all of this Cu2 plus will go here, all of this Cu2 plus will go here, all of this Cu2 plus will go here, okay. And as the Cu2 plus goes here, the electron which they have lost also goes, okay, goes traveling all the way from here, and then they go here, and then it is the same 2 electrons which they lost, which they will get back again. All right, so I hope you understood, okay, how copper receives the 2 electron, okay. So the same copper atom which loses the 2 electron jumps into the solution, jumps into the electrolyte, and dives all its way to this. In the same time as the copper ion is diving its way, this electron is also making its way here, okay, just to meet up with the same, okay, just to meet up with copper ion again. So on touching the cathode, it will receive the 2 electron which it lost earlier, and then it will deposit it on the cathode, okay, it will deposit in the cathode. So the copper atoms, all the copper will get deposited on the cathode like this. So this blackish thing which I'm drawing here, these are the copper metal which got deposited in the cathode. So the cathode, okay, deposition of copper metal will take place in the cathode. So with time, what happened? The cathode, the deposition of copper on the cathode gets more and more, gets more and more, gets more and more. So the cathode gets thicker and thicker with time. Whereas on the other hand, the anode, what happened? Because the copper metal, okay, the copper are escaping out in the solution. With time, the anode becomes thinner and thinner. So with time, this anode becomes thinner and thinner. Okay, and at the same time, okay, and at the same time, when the copper metal jumps in the solution, the impurities which are present in the anode, they fall down and then they get deposited at the bottom. Okay, these are the impurities, and these are called as the anode matte. So these are called the anode matte. Okay, these are the impurities. These are the impurities. So these are the impurities which is derived from the anode. So the impurities, they settle down at the bottom of the anode, and then they are called as the anode matte. Whereas the pure copper, the pure copper, they convert into their ionic form. They jump into the solution and they convert, and they dive all the way. They make their way all the way here. Okay. At the same time, the two electrons which they lost, they also head back here. So they reunite again, and then this time they deposit on the cathode. Okay, they get deposit on the cathode, and this is how, okay, and this is the copper metal that we are after. And so this deposited copper is pure copper. So what we do is we stop the experiment, we take out the cathode, and then we take away the pure copper. And this is how you have managed to refine copper, okay, from the impure anode. So all the impurities down here, all the copper deposited here, and this copper, this is pure copper. This is pure copper, which is 99.99% pure. Okay, and this is how, okay, this is how electrolytic refining of copper is done. Okay, so it's not very difficult. Okay, of course there is so much to remember here, but if you study once, twice, okay, you will get the whole process. Okay, so you can always rewind the video, and then you can always check out the points you are missing. I've made sure that I did not miss out anything. Okay, I don't think I've missed out anything. Okay, I don't want to miss out anything here, because if I miss out anything, the knowledge, the idea that you have will be incomplete. But I believe so, I have not missed out on anything. So this is it, my dear students. This is it. So before I leave you, okay, I have a question for you. So let me write a question here, and then I want you all to hand me the answer. The answer is from this discussion only. Okay, so the question for today will be what is the anode? What is the anode made up of? So the options that I have to give you are: is it made up of the impure metal, or is it made up of pure metal, or is it made up of the metal ore, or is it made up of what should I give you as the option? Let me just try like this. So like this. Okay, so this is the question. The question is, what is the anode made up of? Is it option A, impure metal, option B, pure metal, option C, the metal ore, or option D, the bulk cell of the metal? So please comment the right answer in the comment box. I go through all your answers, and I make sure that I verify your answer. If the answer is correct, I will say it's correct. Okay, if it is wrong, still then, okay, I encourage participation. So whether you are correct or wrong, participation is what counts. Okay, so feel free to participate. Okay, and all the questions which are posted are based on the topics which are being discussed only. So with this note, I'll conclude the video from here, and I'll see you again in the next video.